Welcome everybody. Thank you for joining today's live Lansmont product update, where we'll be showcasing Lansmont's PDT 300 and PDT 80 drop testers in action. This is a unique opportunity to see these drop testers perform and get your questions answered by our VP of Technology, Eric Jonasson. Lansmont is a proud member of the Physical Properties Testers Group, or PPT for short, and we are a collective of specialized brands in physical properties testing. PPT covers areas such as tensile and compressive strength, torque testing, textile analysis, force testing, and real-world dynamics like shock and vibration. Alongside Lansmont, our family of brands include McMesson, James Hill, and Telluris. To learn more about PPT and our individual brands, you can visit the PPT site or take a look at our on-demand content. I will make a link available in the chat box for your convenience. Many of you already know today's host. It is Eric Jonasson, our VP of Technology, and I'm Sharon Smorenberg, one of today's organizers, but we are supported by a dedicated team across the United States, Europe, and Asia. As always, we encourage you to ask questions. Throughout the webinar, use the question box to submit any questions you may have, and we'll address them at the end of the session. The webinar is again being recorded, and you'll receive a copy of the recording via the email that you registered with. You're welcome to share this with whomever you think will find it of interest. And with that, I'll hand over to Eric.
Okay, thanks, Sharon. I assume you can hear me. I apologize for the noise in the background. If you can hear that, there's a compressor running at the moment, which is part of the overall show. So, hello everyone. Hopefully my camera's on. I am here live at a laboratory that's Package Dynamics Testing Laboratory at Michigan State University, where we have some Lansmont equipment, and it's close to where my office is. So I'm using this today to showcase these two pieces of equipment. Specifically, I'm going to talk about all our drop tester family pieces of equipment, but I'm going to highlight these two pieces here with me, the PDT 80 on my, I guess that would be the, I'm trying to decide which side it is for you. I'm looking at my screen, but over here, PDT 80, and over here, PDT 300. So I'm going to focus on both of those, show you the operation of them, show you some of the key components, kind of introduce you to that type of hardware. And it's nice that they have both of these here at this location. But before I get into that, I'm going to share a couple slides that talk about the whole family, but trust me, it's not that many slides. The nice thing about doing this live is I'm going to do mostly talking and showing. I've got a separate camera here that I'm going to turn on a little bit later. So we'll have two cameras in operation. Even though Sharon is a wonderful help in putting these events on locally, I'm here by myself. So this should be interesting to see how a one-man or one-person operation functions with multiple cameras running pieces of test equipment. So appreciate your patience with me, but I think it's going to work out. And I'm looking forward to, again, showing you things and certainly open to any kind of questions and other demonstrations, pointing cameras at other locations or showing specific operation when we get to that point. So right now I'm going to go ahead and turn my camera off, go back to sharing my screen, and go through a few slides. See you in a minute. Okay. So if everybody can see my screen now, this is our family of drop testers. We basically have 5 different models that we offer: PDT 80M, PDT 80, PDT 300, PDT 700, and what we call the QR 3000. PDT stands in our terminology for precision drop tester. QR stands for quick release. So it's a quick release hook, and I'll go through each of those here in the next slides. I guess I'm gonna have to operate with my hands here, sorry. So the family of instruments, this is a table that describes the unique characteristics of them. There's not a lot of real unique characteristics other than really what determines the uniqueness of them is their payload capacity, the footprint of what you can test, and the payload, how heavy it is. And so you see from left to right, PDT-80M, what that M stands for is manual operation, meaning that you have to move the drop assembly up and down by hand versus using electric hoist, which all the other ones use to operate and position the hoist vertically up and down. So the PDT-80M is only different from the PDT-80 in that it doesn't have a hoist. It's got a spring-loaded mechanism that makes it easier for someone to move that drop assembly up and down on the guide rod and then be able to pin in place. What the numbers mean in each of the names, PDT-80, PDT-300, PDT-700, that is in relation to the payload capability of each of the drop testers in kilograms. So PDT-80 and PDT-80M both have the same kilogram, payload capacity. The only difference, like I say, is one has a hoist, one doesn't. But they're basically the same systems as far as their operation and their payload and the size of the platens. Everything's similar except for the hoist. The PDT-300 and the 700, so there you get 300 kilograms with the PDT-300 and 700 kilogram payload capacity on the PDT-700. So much bigger, much larger, and they are very similar to each other, right? So the design of those and the operation is very similar, the 300 and the 700. And I'll explain that or show you that here as we move forward. I'm not really going to talk about the QR3000 because one, we don't have one here, but it's, it's also kind of it's a very simple mechanism, piece of hardware. Basically, you attach it to what usually is a chain or straps and sling that somehow from a cross member like I have here behind me that you'll see. And then you use a foot switch to release whatever is being held by the quick release itself. There are basically jaws inside there that open up and close based upon whether you're depressing or releasing a foot switch mechanism. So very simple. So I'm going to focus on this family's here. So again, another way of really looking at these are maybe different categories instead of 5 different models. I look at them as like our standard, weight systems, our heavyweight drop testers, and then really this is extra heavyweight. I should also point out that the QR3000, even though I told you that the PDT-80, 300, and 700, those numbers reflect the kilogram payload capacity. With our wonderful Once Upon a Time naming convention, the QR3000, actually the 3000 stands for pounds. Don't ask me why. I probably was involved once upon a time, so you can blame me. But in that case, the QR3000 is a 3,000 pound capacity piece of hardware. But since we have these 2 different families on the left, what I'm calling the standard weight and the heavyweight, they are the designs of each of those. The 80 and the 80M are similar, and the 300 and 700 are similar. So I'm going to focus, just because also that's what I have available here in the lab behind me, I'm going to focus on the PDT-80 and the 300, point out the unique characteristics of each of those systems and how they work and operate. And just before this, I know this is some small detail, but when we talk about some of the besides the payload capacity associated with these, some of the options that people ask about are, hey, does it come with some way of holding, a device or attachment that can hold the DUT, the device under test, the package, the box in certain orientations when I'm dropping it. So we call that in our naming convention, we call that an edge and corner holding fixture. And so that's basically, looks in that top left thumbnail, it's a gooseneck that comes off of the machine or the cylinder that I'll show here shortly, and holds the package in place. So we do offer a couple different options for edge and corner holding fixtures for this model. We do offer larger platens, drop leaves, that's the second thumbnail you see down there, not only longer in length, but also wider. So it can handle, larger or unique size packages. So we do offer what we call extended platens. Again, it's extended in length and extended in width. And so those are options. And then for this specific model, the lowest drop height is limited based upon the size of that platen. So if you have basically, let's just say you have a 12-inch platen, well, you can't drop any lower than 12 inches because the platen needs to rotate out of the way, from its, and I'll show you that, but from its flat parallel to the ground, but then it rotates backwards out of the way. And of course, when it's fully back, those 12 inches are pointed down towards the ground. So when people have a requirement to drop below that minimum drop height, it might be 12 inches, or it might even be 18 inches, depending on if you have a long platen as part of your standard system. We offer something that's called a slotted base plate. And that slotted base plate is basically, you pour concrete with slots in the base of that concrete, so that when you drop or activate the drop mechanism, the drop leaf assembly on the PDT, those leaves go down, the arms of the drop leaf go down into the ground, allowing you to go very low, obviously, within drop heights. So that's called a slotted base plate. Touching on a few of the things over on the PDT 300, we do also offer an edge and corner holding fixture for that device or for that test system. And we offer extended carriages. In this case, they're not wider, but they can be longer. We're kind of fixed on the width with these carriages, but you can go longer with these. So we do have extended drop, carriages available for those people that have very large products. And then we offer what's called a steel base plate system. So if you look at the picture on the right, you see slots in that base. That's basically what I'm talking about, is the example over on the left-hand side with the slotted oversized base plate on the PDT 80. You have to have those slots one way or the other in either the ground, poured in the concrete, or raised, if you can't do a special foundation in your concrete, you can purchase something like this, which is a steel base plate. You purchase a bunch of steel, which allows that drop leaf to travel into the ground, basically, and away from the package, and not rebound back up into the package once it enters into to either the ground or below the grade of that steel base plate. So we do offer that. It's expensive steel just to have in place. The easiest way to do this is to pour a special foundation. And I'll show you what that looks like here. So, and this is just, what I wanted to mention here is we offer training. So I realize some of you might not even have our drop testers, but the fact of the matter is we have a lot of good content. If anybody is interested and has a drop tester or is considering it, on training. We call it drop operator certification. It's product specific. I have all this stuff shown in grayscale right now. It's more interesting. It's more colorful in person. But we do offer this where we go through every key component of the individual drop testers, the basic machine structure, all about the individual pieces and what they do, safety, operation of the system, test setup, and then things like PM and care. So this is, just showing some slides or pages out of that training material. We go through each one of these things, and I think that's a nice thing, helpful, beneficial, that we can offer to help people get familiar with these if you ever, if you have one or if you're considering purchasing one. So this is nice support material in addition to the kind of things I'm talking about here today. So it's just a video. And I realize, again, it might be a little bit glitchy, but basically a video showing the PDT 80M, the PDT 80, bigger platens, dropping bags, heavy bags of dog food, bag in the box operation, a PDT 300, and even a PDT 700. So instead of that, though, instead of any more videos, I guess, well, we're going to watch a video, but I'm going to turn the camera on and we'll see how well this goes in person. I'm going to stop sharing my screen and turn my camera on. Hopefully you can see that. And then what I'm going to go ahead and do is I'm going to go ahead and over to my second camera, cross my fingers that everything works here. turn my camera on. My second camera. Cool. I think it's working. Sharon, maybe you can just give me a quick verbal yes.
It's perfect. Thanks, Eric.
Okay. All right. So, all right, here I am in two different screens. So I'm gonna spend my time now over at the machines, walking you through each one. I've got my other camera on a tripod at the moment, but I'm gonna take it off that tripod. I'm gonna walk you through, the basic structure, kind of key components associated with the PDT 3, or excuse me, the PDT 80. Show you what all those different pieces are. Then I'm going to go ahead, I'm going to do some drops. I'm going to do some drops of this package using the handheld control. Then I'm going to do some with the foot switch. Then I'm going to go over and move the tripod and do the same thing at the PDT 300 next door. So I'm going to start here at the PDT 80M. This is kind of a nice view, and we'll come back to this when I actually drop things, drop this package. But I'm going to take you off the tripod right now and do a little walking tour. And hopefully I won't make anybody sick. I'm going to be stable. I promise, as stable as I can. But I'm going to do this. I'm going to leave the other camera on. Might be a little bit awkward for you to see me moving my hand up and down, but at least it gives you some perspective as to the scale of the piece of equipment and everything. So I'm going to start at the top of the machine, eventually go down the machine and in front of the machine and talk about these key components. The heart of the matter, or the main key components, are associated with this drop leaf assembly. But can't might as well start at the top, right? And so, this is a PDT 80. So what do we have at the top here? We have a hoist. We have a hoist and what we call a junction box. And that's basically where the power comes in. You can see a power cable going up there, which powers the hoist, as well as some low voltage stuff that's down attached to the drop leaf. But there's really not too much going on up at the top here. It's a hoist. It's a junction box, we call it J box, with all where the power comes in, and then there's also an encoder on our standard systems. Basically, you can and it counts. So if I focus up there, it's a little box at the underneath side of the plate there. That's basically a counter, a drop counter that helps us understand, and you understand how much usage you're getting out of your system and keeps track of it from a preventative maintenance perspective. So that's it, hoist, junction box, encoder, counter, and then hoist, the chain from the hoist comes down and attaches to this drop assembly, and that's what raises and lowers this overall assembly up and down into the desired drop height where you're going to perform operation. Yeah, there's a cable that comes down from that junction box to what we call this valve plate on the back side inside this box. I'm not going to open that up and show you. There's not too much going on inside there as far as the amount of hardware, but it is a key, obviously, location. That is where the pneumatic valve is that fires the system. Basically, it takes pressure. So you can see on the back side, the system, I apologize, it's a compressor running in the background. It's real. I can't turn it off right at the moment. But you see this hose coming from the corner of the door, comes into this room behind me. There's a closet with a compressor. Hose comes into this cylinder on the back side of the drop tester. And that's just plant air, right? Basically, this machine runs on 60 PSI. That's pretty much what you would set this at, 60 PSI. So pressure comes in here and eventually comes into this valve plate through a hose on the bottom side of the cylinder. And that's what is used to fire the system to drop. And that's, again, I'm going to get to that point, but that's much more interesting than what I'm showing you so far. So simple, plant air, it says 40 PSI. I'm having it set at 60. Either one of those, it should operate perfectly fine. Doesn't use a lot of volume of air because all it's doing is, when you drop it, goes boom. Basically, it's enough pressure to fire a piston inside here downward that forces the cylinder rod here that's attached to the drop leaf assembly. It shoves it down fast, fires it very fast and, mechanically speaking, very violently to get it out of the way of whatever package or product that's being dropped. And when it does that dropping, you'll see that there is a little hose also that comes from that valve plate to here, to the back side of the drop leaf assembly or housing assembly. And what that is when you hit arm, you would hear a sound, a pneumatic sound. And what it's doing is it's locking this system. It's making it stable and locking it in place on this guide rod. There's basically a puck inside here that once you apply pressure, it pushes into the side of this guide rod to hold it in place so it's stable during the drop. So otherwise, if it wasn't, the whole thing would be rattling, which would be, potential for upsetting the control of the drop and also more abuse on the system itself. So let me just drop this package off of here for the moment. I'm going to drop it on the ground. Here you see the drop leaf. This is, again, the key component. We call this blue guy a drop leaf. And what you can't see, I guess unless I bend down, you see there are a couple forks there. Those are part of that blue drop leaf. And then what's mounted to the top of that drop leaf is a platen, an aluminum platen. This is a standard platen, 12-inch platen that attaches to that drop leaf. And so what happens when you would drop this assembly or fire this assembly is pressure, big volume, bigger hoses, pressure comes into the top of a cylinder inside here, and it fires that cylinder downward. That cylinder is attached to this drop leaf, and what it does is it pushes it down, and it pushes it down, accelerates it faster than gravity. Why is that important? Well, it's important because what that allows the platen to do is separate from whatever's being dropped. It's moving faster than gravity, right? Because it's being accelerated. And that's key or critical to achieving flat drops without any type of rotation, because you have to have that separation. If you didn't accelerate any faster and that drop leaf just kind of rotated slowly out of the way, it would impart rotation on whatever was loaded onto the drop leaf assembly. So that's basically, the key parts here is that this cylinder, again, fires based upon pneumatics coming through a valve here, fires that cylinder arm down, which pushes this out of the way, and then this goes, during the drop, this goes straight down for about 6 inches, and then once it's down and out of the way, it rotates out of the way. And what might be hard to see, and again, I can't show you this without taking covers off. I'm not going to do that right now, but since I have the camera, you can see a couple roller bearings. That's a bearing in there, and that's another bearing. So there's two on each side. There's two here, and there's two over here. You can kind of see them probably. It's harder to see, but they are both there. And so inside the side of this housing here, there's a track that those roller bearings are able to travel in. And the track looks like something like this. It goes down, and the track goes like this. So what happens when you fire it, it goes down, out of the way, down, out of the way. And of course, those tracks are on both sides. And so that's what allows you to fire downward and rotate back in that cam. And last but not least, handheld control. Both of these systems I'm not going to go through all the capabilities of the handheld control, but I'll show you what it looks like. Handheld control, which is used for positioning of the hoist or positioning of the drop leaf assembly up and down into the desired position. And it's also where then you can obviously arm it and drop it. You activate that with the handheld control. The machine also has what's called a foot switch. And I'll show you the operation of both of those. So you can actually trigger drops using either the handheld control that's hanging back there or the foot switch. And I'll demonstrate both of those right now. And so to do that, I'm going to put you back on the tripod. And I'll make sure that I think anyway that I have you positioned. And Sharon can give me some type of.
Yes, that's good. Thanks, Eric.
Okay. Thank you, Sharon. So I'm going to go ahead and put my package on here. And then what I'm going to do is I'm going to grab hold of my handheld control, and you'll see it. And of course, I'm going to leave it down, so I'm going to arm it. And if you can maybe hear a click. That's the pneumatics where it's coming into this puck and locking on the guide rod. I arm it, it's locked in place, I drop, it rotates out of the way. Before I reset it, you might be able to see, I'll walk you in there because I can do it one more time. I'll take you off the tripod, walk you in there. This gives you an idea of now that it's in this down position, the cylinder is fired downwards, you can see those slotted cams, right? You can see that on both sides to a certain extent. Those are the cams that the roller bearings travel in. So, it's harder to see the backside ones, but they go down and then the position of it rotates backwards into that position. I might be able to show you a little bit there. It's harder to see, but that's how that works. And that's key. So I'm going to go ahead and do one more drop, and then what I'm going to do is oh, sorry about that. I'll make you sick. I'm going to reset it. I have the ability to reset here. Reset, it comes back slowly, safely. So that's an adjustable setting. We always make sure that that is coming back safely so it doesn't surprise anybody and get anybody kicked back and potentially hurt someone. Rotates back slowly into position. Arm it. Well, arm it, drop it. Hits flat. I'm going to reset it. What I'm going to do right now is I'm going to switch to the foot switch mode. Okay, so I just did that. So there's an operation on the handheld control to switch it to foot switch control. So right now, what I'm able to do is walk over here and just using my foot, that same package, I can do drops. So now if I've got my foot inside the foot switch, as soon as I depress that foot switch, it's going to fire. Okay, so I'm going to do an edge drop. In this example, I'm going to put the box on the edge. Instead of using an edge and corner holding fixture, I'm going to find basically what I feel like is the CG, where it's standing on edge. And normally with a packaged product, you can feel that, right? So I'm going to kind of balance it on that edge, and then I'm going to depress the foot switch. And now my foot, if I release my foot off of the switch, the platen comes back up. If I want to do a corner drop, my foot is still pushing down on the switch, so the platen's not coming back yet. As soon as I take my foot out of there, platen rotates back into position. So this, I would say, and for if you're doing ISTA standards, ASTM standards, any maybe even corporate drop test standard, where you're dropping packages 10 times, maybe 15 times in a row, or you're doing multiple samples where you might be doing 50 drops. It's pretty typical for people to be using a foot switch operation. So you use the handheld control to get it to the position that you want it. Then you switch it over to the foot switch mode of control, and then you're over here, interacting with because you're picking up. You're changing the orientation, face, whatever face it may be or whatever edge it may be. You're dropping. That's very typical for people operating in a test lab. And it also is why most people, I would say, do not use the edge and corner fixtures. Yeah, they work. You might think of them as being comparatively more safe, but the fact of the matter is they can be cumbersome to use. Especially in high volume testing where you're going to be doing lots of drops. I would say most people are using their edge and corner holding fixture tends to be their hand or their fingers. So that's kind of a quick overview of the PDT 80. What I'll do is I'm going to just drop this one more time, and what's important here and interesting is when it fires, and it rotates out of the way, you can't really tell maybe here, but if I go parallel down with the face of the machine, this platen is behind this face of the drop leaf assembly. And that's important, right? Because if you have a package on there and you're dropping it, and it's basically at the point of where you're dropping it right now, that package is here, close to the drop leaf assembly, When it fires, you don't want the platen to maybe be protruding outside of that face, or you don't want it, when it hits, rebounding back into the package, which basically you can think of would be like drop kicking it across the lab. It has to stay after it fires and does this violent motion. It has to stay behind the face of this operation. So we do that. You know, that's a quite frankly a challenging thing to control. But we do it. We do it with an air cushion. You know, basically what happens is it rotates out of the way, and we use air on the bottom side of the cylinder to provide cushioning or dampening, so that when it hits, it doesn't rebound back into the whatever's being tested, the box that's being tested. Okay, so I'm going to move you over. I'm going to move the tripod over to the 300 and talk about that here real quick. Trust me, I'll rotate you back in. Okay, so I am going to focus on this machine here. Even though I just moved you to this position, what I'm going to do is I'm going to take you off the tripod again. And what's kind of unique with this system as compared to the 80, here the 80, this whole assembly moves up and down, but during drops, the only thing that happens is that drop lead swings out of the way, down, out of the way, down, out of the way. All the action happens right there. This whole assembly doesn't move up and down. And that's okay for this. And it's really based upon, you know, why that's acceptable is the payload capacity up to 80 kilograms. It can handle that violent motion. Trust me, there's a lot of force and stress put on this whole assembly when you're dropping it, you know, not just the drop in release of a heavy payload, but when it kicks back, it's got to be very durable to handle that. Well, this one steps up, right? Now we're stepped up to a much higher payload capacity. 80 versus 300 doesn't really sound like maybe that much of a difference in kilograms, but you know, it's nearly 4 times the payload capacity. So that's a big deal. So in this case, we don't, you know, it would be too stressful to have 300 kilograms, excuse me, sitting on that drop leaf assembly and stressing that system out. So a swing arm operation for that payload isn't practical. So in this case, what we do is we go to assembly, this blue assembly. There are forks that are down in the floor here. You can kind of see they're slotted. So there are forks, blue forks, that are attached to this assembly here. And this entire assembly, blue assembly, moves up and down on this big heavy-duty steel I-beam using roller bearings. You can see a couple of the roller bearings there. There are 2 more down at the bottom. And on the back side, we have the same thing. You see roller bearings. So what happens is the hoist, this has a hoist at the top, just like the other one does, and that's really all that's there, a hoist and a junction box. That hoist is used to lift and lower this drop leaf assembly up and down on that I-beam. But the difference here is that assembly, instead of just swinging out of the way, that actually does get released and goes down into the floor every time you drop it, which is another big kind of violent and challenging thing to handle all on its own. And so how does that operate, or how does that work? Well, again, chain raises and lowers that entire blue assembly. You can see it's attached here, and it grabs on, might be hard to see it, but there's a roller pin here and an air cylinder, rotates over a roller bearing, and then that grabs a hold of the blue big assembly and lifts it up and down. And when it gets to its drop height, desired drop height that we set with a handheld control, just like on the PDT-80, what happens is we use air to trigger this to release, roll off of that bearing. And when it does that, what you can see down in the pit here is, this is a spring reel system, okay? So think of it as like a big rubber band. And this is attached with tension to the bottom of this drop leaf assembly, this cross member, which is tied to the drop leaf assembly. So what happens is when we drop, you know, with our handheld control and release this, that spring reel system under tension pulls. It pulls it down, and that's critical once again, because we need, right, if we're going to do true free fall drops, we need to have separation between the forks and whatever's being dropped. So that's how that system works, is we use air to release the drop leaf assembly. The spring reel system basically pulls or accelerates the entire system down into the ground, which, like I say, is also in its own way kind of a violent action, because all those forks need to be able to withstand that abuse. Not only hold the load and the releasing of the load in a quick time frame, but then it hits the ground, and that can be its own big violent impact. And I'll show you here. I'm gonna put you back on the tripod as I operate this to make sure I'm pointed the right way. Sharon, again, can you tell me if that looks basically okay?
Yes, that's perfect. Thank you.
Okay. So I think the first thing I'm going to do is I'm going to just move this packet out of the way. You can see the fork or the slots in the ground. Okay. So what I'm going to do is just raise it. So there comes the platen. You see what the platen looks like, right? So, I say it's a platen, but it's really a drop leaf assembly. It's these fork tines. They're all tied together. So it's structurally rigid, secure. And that moves up and down. So I would move that up and down to a set drop height. And what you see, let me just see if I can see it on the camera. Yeah, you can see it. See this is a damper here, spring-loaded damper. That's what we use once this gets down into the ground to help cushion the blow or the impact of that hitting the ground. So once it gets down into the ground, it contacts that, and that cushions or absorbs the energy of all this mass falling down into these slots. In addition to that, too hard to see, even if I brought the camera over here, but inside the base of all these slots is what we call zorbothane, basically like a rubber material with a certain amount of stiffness or softness, cushioning. Basically acts as big cushioning. So everywhere in those slots is cushioning. So that works in tandem with this guy here to absorb the energy of a big drop and make sure that there's also no rebound when it happens. So what I'll do is I'll drop it without the package, and then I'll do it with the package. So I set it up for an 18-inch drop. It's there. I arm it. I drop it. Down it goes. In this case, now I have to lower the chain down until it's over that hook. I reset it. The hook rotates back into place, and now I can pick it back up. Okay, so what I'll do in this case is now I will push this big box, fairly heavy box, onto the tines, and I pick it up. And I go back to 18 inches. Stops automatically at the drop height. I arm it. I hit drop. Boom. I come down till the hook is in place over the roller bearing. I reset it. It's ready to now pick it back up yet again. Like that. So that's how that operates. You can still do edge and corner drops, a little bit more challenging here, but certainly edge drops are not that challenging. And again, you can, depending on if you have really big packages, we can go longer with fork tines, quite a bit longer. So you can get more space to do things like edges and corners. Corners are a little bit harder to do, but they can be done. And what you can do is you can actually put the corner through the slot and start lifting. Typically for those kind of unique drops on this machine, which I guess should be facing the other way, and these kind of machine, I would say they tend to be two-person operations if you're going to do things other than flat drops, because you need two hands always. This one doesn't have the option of using a foot switch control, right? You got to have two hands from a safety perspective to operate this, because you have to hit arm and drop, two hands, two different buttons simultaneously to activate this thing. So if you're going to be dropping these kind of packages in orientations other than flat faces, you typically need a second operator to help with those drops. They don't have their edge and corner fixture mounted here right now, But you can see a rod here that's attached to the back side of the drop assembly. This is where the edge and corner fixture slides on top or over that rod and then swings in different positions here to allow you to lean up packages to that fixture. And again, it works, but what I would say most people do is use people for those drops that require that kind of two-handed operation. So with that, I think I've covered everything that I wanted to cover. And now I would be happy and willing to entertain any specific questions or show anything that other people might want to see, if that's okay. Is that good, Sharon? I don't know if there are any questions, but I'd be happy to try to address those or show something more. That answer questions, show more. Let me have
Thanks,
it.
Eric. I will take a look to see if
Okay.
I know there was one question, but you kind of answered it during your presentation, so I'm not sure if
the other thing I'm going to just do real quick. I didn't think I'd have time to do it, but you know, what I have here set up over here, I don't have it attached to a package. This is our test partner data acquisition system. Okay, so this is software data acquisition. This is a triaxial accelerometer, okay, that I'm showing here, which plugs into the back of our test partner hardware. 3 channels, X, Y, and Z, plugged into channels 1, 2, and 3. You can see that. X, Y, Z, 1, 2, 3. And this is what a small little triaxial accelerometer looks like. So this accelerometer measures G's, acceleration versus time. And you can attach that accelerometer, obviously, to, this is just one example of a pretty decent size that could be used to attach to your product or something inside packaging, anything that's being dropped. And it will allow you to measure the response, you know, what you see in a drop like that. So you see 3 different color traces here, red, yellow, red, green, yellow. That's channel 1, channel 2, channel 3. Also, you know, respective of what's plugged in here. X, Y, and Z is 1, 2, and 3. So we're able to measure what those shock pulses look like if we bump that accelerometer or if we drop that accelerometer. The white trace that you see on top of there is what's called the triaxial resultant. So instrumented drop testing can be a very powerful thing. You know, not only just dropping the boxes like we showed here, or dropping this box, but if we instrumented, depending on what your product is, it might not make any sense, but in some cases, it might make a whole bunch of sense. If you know something about the fragility of your product, you can attach instrumentation to that product and determine whether you know, a couple things. One, did you exceed the fragility, or is it below the fragility when I drop this from, in this example, 3 feet or 36 inches or 1 meter, or you know, maybe 24 inches. Or a half a meter. Did I exceed the fragility or am I okay? But in addition to that, you can also use it to do comparative, you know, compare the performance of different packagings. So if I change inner packaging, you know, if this had some type of product or component in here that has, you know, a fragility associated with it, and I use one type of inner packaging, foam maybe, or some type of new fiber-based packaging materials, does the fiber-based packaging material perform as well as the the polymer-based packaging materials? You can compare one way or the other, and you can obviously, you know, trend. So it's comparison, but you can also trend it one over, you know, over the other for repetitive drops. Is it holding up or is it degrading over time? You can determine that, you know, in quantifiable metrics versus just opening the box, looking at it. Does it look good or does it not look good? You can actually quantify it by using something like Test Partner. So I wanted to point that out, and I just didn't think I'd have enough time to actually instrument something and drop it, but at some, maybe a future session, we could do that. All right, so that's my last, won't move any more cameras around. And if there's
I
no,
have a
I'm
question
happy
for
to,
you,
yep, okay, good,
Eric.
thank goodness.
So how do you determine the appropriate drop height and impact angle for different package types?
Yeah, so industry I mean, there's a couple different ways. Industry standards, so ISTA, International Safe Transit Association, ASTM, D10 or D4169, they, depending on what type of package you have and what type of supply chain you are testing, or trying to simulate, it would have those drop schedules. It would tell you what drop heights to drop from and the number of drops and the orientations. And that it would be the case in both ISTA or ASTM test schedules. In addition to that, what a lot of people do, I don't have one of our Saver instruments because I wasn't really focused on that side of the technology, but those schedules, whether they're industry standards or not, or even corporate standards, are usually driven by something type of known characterization or qualification of supply chain shipping lanes or modes or routes. And so what people do is they'll ship around data recorders, instrumented packages or instrumented decoy packages. You ship those out through your supply chain or through a small parcel supply chain or a retailer supply chain a whole number of times. And what you get back is data from those data recorders, like what I was showing over here on the test partner screen, just like that, that we can equate back to, basically use the measurement data that we get from the field data recorders and quantify that in terms of equivalent freefall drops. So we let the data determine what the orientations, the number of the drops, and the drop height. We let the real world data drive what type of testing we do. And what a lot of people do is they'll use industry standards as their baseline, and then they may, from time to time, check by doing those kind of studies out in the supply chain that says, hey, right now I'm dropping things from 24 inches and maybe one drop at 36 inches. I drop 15 different times from 24 inches, one time from 36 or 48 inches. Is that too severe? Is it enough? Is it too much? And the way they kind of, to check that and validate that is to go do your own supply chain studies. And if it's different, adjust. If the data, you do enough of the data from the field collection and observations, not just even the field data, but if your damage that you see, if I drop this 15 times right now, and this, boom, I hit it on these corners and that corner gets completely damaged. If you don't ever see damage like that in your supply chain, that might be an opportunity, right? To either lower the intensity of your testing, meaning the total number of drops and or the drop heights that you're performing, or it might be an opportunity to change your packaging because depending on which direction, which side of things you're on, that it's not just the field data, but it should be kind of we call that damage correlation. What do I see when I do this kind of testing in the lab with my package? The transport packaging, but also the inner packaging and the product. What does it look like after I put it through, 20 drops as part of my laboratory test protocol? If it looks worse than what I ever see in the supply chain, and I have really good visibility of the damage metrics in the supply chain, I would say that's a perfect opportunity to say, maybe we now have enough information or data to lower the drop heights and lower the total number of drops. So that was a long answer. Hopefully that helped a little bit.
Thanks, Eric. Just one more question. How do you ensure the accuracy and repeatability of drop test results?
So what's important here, I guess I'm still on both cameras, right? So what's important, one, is that this platen and that platen, as it sits right now, we want to certainly be sure that it's parallel with the floor. So that if we drop this package and no other influences are taking effect on that package, that if this is level with the ground, that it hits flat on the ground. And why is that important? Well, one, it's important. It's required in ASTM 5276, which is the kind of the procedure within ASTM that tells you the requirements for doing drop testing, dealing with accuracy and control and repeatability. So what that says in that standard is when you drop something, the item can't, so package, DUT, when it's being dropped, it can't rotate. Let's just, and hopefully you can see a couple different, rotate this way or rotate this way, any more than plus or minus 2 degrees, which is actually a pretty tight tolerance, pretty flat. So, that's ensure flatness of drop. If you're doing edges or corners, it allows that tolerance to go out to plus or minus 5 degrees. But what it's really saying is it's important that for repeatability and control that you drop, when I drop in this orientation, that it's going to hit the floor in that orientation. And then not only is it important for repeatability, but it's also important literally for the dynamic side of it, because the way acceleration, think of like a car, automobile, if you have a head-on collision with a brick wall or a concrete barrier or another car, that's about as severe, it is as bad as it could be. That's as bad as the impact as you could take if you're driving down the road. If you hit that same wall at 45 degrees, either direction on the corner of your car's still going to get really dinged up and damaged, but the amount of acceleration that's coming directly at you at the front of your body is actually less. So it's good to have an offset collision. Well, that's the same for packages, right? So if we're trying to challenge packages by doing drop testing in the most severe way and repeatable way, we want this to hit flat when it hits, because all that acceleration is going to come up through the package into whatever's inside that package in this way. If it's even out this amount, all that acceleration, there's still an impact energy that comes into this package, but now in this case, it goes into different vectors. Some of it goes this way, some of it goes this way, and some of it goes vertical. So at times we do want to do a corner drop, but when we're doing flat drops, we want all that energy coming into that direction. So it's important. Lansmont, when we build these systems in our production, every time we build one, we put it through a performance checkout. We run every system. We run it through a flatness drop verification procedure. We have all those documents, we keep all that, we retain all that. We go through and drop from different drop heights, and we film it in different orientations, and we measure it and verify flatness of drop. And so, you can, like for us, we can measure that when you can measure the flatness of the platen parallel to the ground. And there are ways to go do that flatness verification out in the field. It's a little bit more cumbersome because you got to bring a bunch of camera equipment, but it can be done, or you can do it yourself. We could even show you how to do that. Because we verify it when we ship it in our own facility, but there is the ability to do it also in the field.
Thanks, Eric. I think that's all the questions that we have for today.
Okay. Good.
Wonderful.
Thank you. Sorry for the noise again back there. Thanks for everybody, for wherever you are, for first go at this. I hope it was semi-effective, and quite frankly we would, Sharon and I, any responses you have if it was worthwhile, and if you even have recommendations on how to make it better, because we're going to probably plan on doing this with other pieces of equipment, more interactive like this, and be able to walk around and show things more intimately. So thanks for putting up with it.
Thank you, everybody. And if there's any further questions that you have that we've not yet addressed, then please feel free to reach out to Eric directly. And his email address is eric.jonason@pptgroup.com. So, or you can just go onto the you can go onto the Lansmont site, and just use the contact us button, and you can also reach us that way, or reply to one of the webinar confirmations that you've received, and that will come through to us. Thank you very much for joining us. Like Eric said, we hope to be hosting some of these sessions in future, featuring some of our other systems. So please do let us know what you appreciated, what you didn't, what you'd like to see. That would help us greatly. Thank you very much, everybody. Thank you, Eric.
Thank you. Thanks, Sharon. Thanks, everyone. Have a good day.
Thanks.
Good night.
Have a good day. Thank you.
Bye-bye.